Of CosmoQuest Astro Office Hours. I am your host, Dr. Matthew Richardson, and the time is now 12 o'clock p.m. Central Time. Guys, excuse my voice. I'm a little under the weather right now, so my voice might be crackly from time to time, but I'm going to try my best to control it. All right, so today's stream is another work day stream. I'm not going to be presenting um, a problem, or we're not going to be working through a problem today. Today I'm just going to be getting some work done. More specifically, I'm trying to get some plots done for a poster presentation next week. So that is what I'm doing today, and of course, you guys are always helpful with stuff like this, so if you guys see something, let me know. But let me go ahead and first verify that the stream is actually streaming successfully. So let's go ahead and find that Chrome application. There we go. All right. Let's go ahead and navigate to Twitch. All right, so far so good. I see a little red dot for CosmoQuest indicating that someone's streaming. It's verified to me. Okay, yes, that's me. All right, I'm gonna go ahead and pop out the chat. All right, let's do this. Go ahead and say hi to everyone who's currently here. Grace Sal, what's up? Python, no, not Python. This is, so in the top window, that is my Emacs application, and it is written in C++. In the bottom window, of course, is my terminal with a bunch of tabs open. I've increased the font so you guys can see what I'm typing today. But this is the new name, so hey, welcome to the stream. Oh, it does. Interesting. Okay. That is something that I must correct. My apologies for that. Let's see who's all here today. Hello, Electrical Skateboard. Hello, Grace Al. Hello, Michael T. Mayer. Hello, Peter Q. 1978. And hello, RFK Gaming. Welcome to today's stream. Oh, that's a new name as well. RFK Gaming. Cool. All right. And Phoenix. Your name, and Tom. You guys' name didn't show up. I apologize. But hey, welcome to today's stream. And again, guys, my voice is kind of like messed up right now. I'm going to fight through it though. So, actually, I have some plots, or I have some pictures to show. Well, they're plots, but they're animations. And so this is all a part of my incidence angle analysis. So, again, my name is Matthew Richardson. I work for CosmoQuest, and we specialize in citizen science projects. And so one of the projects that I'm currently working on, which is based off of some data that we have, is this analysis I call the incidence angle analysis. And so basically, we have a bunch of images taken by the Lunar Reconnaissance Orbiter of the Moon, and we've requested citizen scientists, or the general public that is, as well as anybody actually, to come along and look at these images of the moon and identify craters within them. And so one of the questions, thanks Ray Sal, and so one of the questions is, does the angle at which the sunlight hitting the lunar surface affect how our users are identifying the craters? And of course, that angle at which the sunlight comes in and hits the lunar surface is the incidence angle. So that is the gist of what my analysis is all about. And so I'm creating some plots for a poster that my that my, give me 1 second. Sorry guys, give me 1 second. I gotta set something up really quick. I want to get these plots up. So I'm gonna switch scenes, and you guys are gonna see some dark space right now, but I'm gonna put something there. Just give me 1 second. Actually, let's go back for now. Let's go ahead and first find the folder where this where the plots are at. All right. Here, planetary slants. You guys can't see this, but I'm just basically navigating to. Oh, it's right here. It's already open. I'm gonna have 3 plots to show at the very minimum. Let's find some good plots. All right. So what I'm gonna do. I think everything with my, let's minimize this. I got a bunch of windows open up right now. It's kind of crazy. All right, I'm going to switch this to 0. This as well, because this is already a plot that I've already made and I know it looks good. All right, let's go ahead and compile. And so there's actually more to the incidence angle analysis. I'm going to now go into more details about exactly what my algorithm is doing. All right. And I will go ahead and run this. You guys should be able to see what I'm seeing, yes. I'm going to go ahead and run it. It compiled just fine. It should compile just fine. If it didn't, I was going to be really worried. All right. And so the name of the algorithm is incidence angle analysis. And I pass it one file, the file entitled LROC auxiliary data. And so basically within this file are all the images that we've taken from the LRO image archive and we use for our Moon Mapper app, which is the application that our citizen scientists access to be able to annotate the images that we have. Let's make sure I'm keeping up with some comments here. Hey, Peter. All right, and so it should have already ran and stuff. Okay, and I've generated 4 images in total. And so I'm not going to go ahead and navigate over to another scene that I have here with the blank screen. And let's go ahead and pull up these images. Let's pull this one up. What does this one look like? All right, this is one of the images I want to show. So going back to the OBS software, I'm going to go ahead and, let's see, plot. All right, does it show up there? Preview. Perfect. All right. All right. So next week, my postdoc mentor is giving a poster presentation at the LPS conference. I think LPS is short for Lunar and Planetary Science Conference meeting. It's held annually. And like I said a few minutes ago, she's going to be giving a poster presentation, and I'm producing some plots for this poster. And so one of the plots I've produced is the one that you see here in front of you. And so this particular image is one of the Lunar Reconnaissance Orbiter images entitled, as you see at the very top, the M. Let's see if I can scroll up a little bit. M1092156991LE. This image was taken by this particular image was taken by the narrow angle camera aboard the Lunar Reconnaissance Orbiter, which is currently orbiting the moon. And so to kind of give you an idea of what the image looks like, I might open up another scene. Actually, we can just do this. Let's open up a web browser. Let's do this so I can show you what the image looks like. That's good. Go back here. Let's go ahead and type in internet. All right. Let's go ahead and adjust this so that you can see the entire screen. Video capture. All right, perfect. And so this particular image, so I'm going to go ahead and navigate over to the LRO image archive. WMS. Okay. So you can see what the entire image looks like. So image search. And then I'm going to get back to my plot in a few minutes. Now, for those of you who have seen my previous streams, you kind of know what all of this is about. All right, so I need to get that image name back again. I think I can do it from here. Let's see if I can just... I'm just going to simply copy and paste it in. All right. So that's going to load up, and then I can show you the image. And it is not done loading just yet. There it is. It's done loading. All right. So now we can go ahead and view the image. Now we've taken 26 of these images. And so you can kind of see the image here on the right hand side of the screen. I'm going to zoom in a little bit. And so we have 26 similar images. That is, they were all taken by the Lunar Reconnaissance Orbiter, and they, for the most part, image similar fields on the lunar surface. And so the image that we actually have that we have in our database for this is actually a sub image of this image I'm showing you. So I'm going to go ahead and zoom in. I'm going to see if I can quickly find the section that we're actually using. Not there. Here it is. Let's hope you can see it. And so the section that we're actually using, I'll zoom out a little bit. It's kind of like in this region of this image that I'm showing here. And so we've taken this section of the image, which is still a pretty big image in itself, and we've cut it down into slices. And so now what I can do is I can go back and show you my plot. What happened? Oh, I see. All right, perfect. And so basically what my plot is doing is it's reconstructing not only the boundary of the image, which is the green background, but the blue boxes that overlap the green background represent, and let's go ahead and zoom in on the legend there so you can see what that's all about. So preview. All right. And so basically the green background represents the actual boundary of the image that we have in our database. The blue boxes represents the sub-images. So we've taken the entire image and we've sliced it into little smaller images. And the smaller images are what our citizen scientists are using to annotate and mark craters. And then there's going to be like a little red dot or circle, which is going to be along one of the corners, which represents the origin of the image. And the origin for the image, you think of it in terms of if you were looking at the image itself, the upper left-hand corner would correspond to the origin. However, within my algorithm, the corner of the image is going to be different because of how I've set up my coordinate system. So I'm going to go ahead and zoom out. So the origin of every single image, image slice, or just general image in general, or any image that we have within our database, the origin will always be the upper left-hand corner. Why can't I zoom out? What is going on? All right. I can do that. I can't zoom anymore. It's not letting me zoom using my... All right, I can do that. but I can't zoom in and out. Let's do this. Ah, silly Matt. Of course, I have to make sure that it's the active window for me to be able to use that feature. All right, so let me go ahead and zoom back out. And so, what my algorithm first starts off by doing, so let's actually talk a little bit about the algorithm a little bit. Let's also make sure that I'm not missing any of the comments, which I probably have. Hey, Susie. Hey, Keeper of Maps. All right. So in general, what my algorithm does is it retrieves some information from our database. And so we store all of our information in a MySQL database. I have my own personal copy on my computer. So let's go back to scene 1. And so over to my terminal. I think I have, yeah. So I have my very own copy of the database that I can play around with, which I'm currently making modifications um, to ensure that the results I'm getting from my incidence angle analysis are as accurate as possible. But let's go up to the Emacs text editor. And so basically what I first started off doing, of course, is retrieving the data from the MySQL database. And so yeah, that's what it first starts off by doing. After I've gotten that information, let's see, what's the next important step in this? Then I go ahead and I establish my coordinate system and make sure that all of the images are being recognized appropriately by my algorithm. And so that's basically what this plot that I was just showing you is showing. So I have to keep remembering to keep switching scenes and make sure that you guys can see what I'm seeing. And so I want to make sure that I don't forget that. So basically what you're seeing here is a plot or a reconstruction of one of the images as seen by the algorithm. And so preview, I'll zoom in. And so, of course, in my legend, the red box, which should be a red circle, but it's okay, represents the image origin as if you were viewing the image, physically viewing it. The upper left-hand corner would be the image origin. However, as far as my algorithm is concerned, the image origin is actually at the lower right-hand corner of the image. And of course, I've switched everything into physical units, so the origin for my coordinate system would correspond to 0 degrees latitude and 0 degrees longitude on the moon. Or 0, 0 in terms of meters. And I've basically calculated the distances to where the image is actually the region of the moon it's actually imaging. I've calculated the distance to that region, and it's being shown here in units of meters along the y and x axis. Now, our image slices, the image slices that I'm showing here in blue, do not perfectly overlap the bounding region of the image. Part of it's because the images are taken at are slightly angled relative to let's say, for example, one of the parallels of longitude. So there's going to, of course, not be perfect overlap with the actual image, with the sub-images in the bounding region. And also there's this space down at the lower right-hand corner of the bounding region that also doesn't have images. Now, I'm not quite sure why that is. I don't think I have those the information for those images in my database in my copy. That's more than likely the reason. But basically, I have 26 images of 26 of these plots. All right. Let's see. And so I'm going through each of the 26 plots and I'm making sure that they're correct. Keeper of maps. That is so much the better way of saying this. Okay, so Grace Al, my background is in high energy astro particle physics. But the research I'm currently doing is more so related to, I guess, planetary science. But I love what I'm doing though, so. And so I'm actually a postdoc at the Planetary Science Institute working on the CosmoQuest project. Hey Disuk, welcome to today's stream. Yeah, well Grace Sal said it's an Emacs GUI. The I'm using it's called Aquamax. So let me make sure that you guys can see what I'm talking about here. So yeah, the upper window, it's an Emacs GUI and it's called Aquamax. I like it. It's pretty nice. I've been using it. I was using it while I was in graduate school, and now I just keep using it because I like it. Excuse me. Yeah, you guys know I can be easily distracted. I saw Peter's comment, his Trump comment. So, huh? Wait a second. Is Octext a LaTeX editor, or is it an Emacs? Well, it could be Emacs editor. I'll check it out sometime after the stream. See what it's about. All right. So, as I was stating, I'm currently. So I'm going to pull up another plot that I have. Emacs is So when I first started graduate school, I was introduced to what is it, VI, and I didn't like it. So someone else introduced me to Emacs, and I've been a fan of Emacs ever since. So Peter, what's going? Yes. No, you're perfectly. You're okay, Peter. Some of the side conversations are very interesting. So just to show you the reason why the bottom row isn't completely filled with blue boxes. I'm going to go ahead and navigate over to my MySQL database. All right, and so you kind of can see some of the stuff I've been playing around with. Let's see. I need to select star from, where is this at? This is M109. So images, where, and if I'm not mistaken, let's do this first actually, so I can show you what I mean. So image sets where application ID equals 1. All right. And so here in the image sets table, I have all the information that I need to know about the overall image. And so basically what it's showing me, of course, is the ID for this particular entry, then the name of the image. Application ID, a value of 1, represents images that are associated with the Moon Mapper app. I'm going to skip priority, I'm going to skip sun angle. Then the next 4 columns, minimum latitude, maximum latitude, and so forth, represent the bounding region of the image. Then I have pixel resolution, description, and detail. And so within the detail, for this particular image, I know exactly how big the image is in terms of pixels. And so the green background represents, or the green background's length and width are directly related to the number of pixels that are within the image. Even though it's in units of meters, if I use a pixel resolution, I can convert it back to units of pixels. Now the reason why the bottom row is, so I'm gonna copy this this ID number, this value of 3. The reason why the bottom row is doesn't have all the blue cells like the rest of the image does is because I'm missing information for that particular region of the image. And to show you what I mean, I'm going to go ahead and go to a different table. This table is titled Images, and it corresponds to all of the sliced images that we have in our database. So I'm going to go to select star from images, where I'm going to change this to image set ID. Image set ID. And I'm going to use a value of 3. I think this should give me exactly what I'm looking for. All right. And I'm going to scroll up. And I really do hope I explained this properly. All right. All right, so we're going to start with this first image. Now, of course, every image that's within my within the plot that I just recently just showed, or the blue cells within the plot, are based off of the information within this table. Hey, Larry. And so this very first image that we're seeing here, M10921569 LE _0 _6. So the very first part of that image name corresponds to the master image it comes from, M10921569 LE. The next digit, the 0, corresponds to the scale at which really it corresponds to how many pixels are within the image. In this case, this image, given that it has a value of 0 for that particular part of the image ID, it has 450 pixels by 450 pixels. The very next number, 6, represents that it's the 6th image slice out of so many image slices for that particular image. So the key thing I want to note though here is in the details portion of this entry. So I'm going to highlight this. Wait, let me slightly move my name so up. I didn't want to do that. That's incorrect. I want to do this. There we go. I'm going to move myself up there. And so the key thing I want to note here is that if you look at the part that I've highlighted and you read along it, it's what format is this in? I think it's XML. I think that's the format. But if you go past the sun angle information and you go directly to X and to Y, you will see that it gives values in between the like for the X entry and for the Y entry. And those X and Y values are the reason why certain cells are not being seen within the plot I just showed you. So I don't have the information for the images that would go in that green space in the plot. But I have information for all the other regions. What's up, Big J? Team Hawking? Oh man, they're always lively. This is actually one of like the highlights of the week when I can get online and actually talk with you guys. Let's see. All right, so let me actually get back to what I wanted to do because I have to get this done. All right. So, let's move on to the next image that I was working on. All right. So all right, I'm going to go back to scene 2. And so I'm going to load the next image that we have in our database. So let's see. How do I want to do this? So let's first go navigate back to scene 1. And let's go ahead and create those plots. To do that, I'm going to minimize this. To do that, I need to go back to my Emacs text editor. I need to scroll back down to, scroll up. Here, and I need to change the index value from 0 to 1 for both of these. All right. With that being done, I can now go back and recompile my program. It should compile just fine. My fingers are always crossed when I get to these points with streams. Just hoping that I don't get any sort of errors. All right. And so now I can go ahead and create the plots. Sorry, give me 1 second. I'm gonna go ahead and create the plots now. All right, so you guys can see it's gonna like output some information. Basically, within my algorithm, I make sure that certain things don't take a very long time. It's going, it's going, it's going. And it's done. There we go. What is this again? All right. So let's go ahead and navigate back over to the other scene. And I'm going to change this picture to something different. Or I'm going to change it to the next. There we go. I'm going to change it to the next image or plot. Let's see. Here we go. All right. So this is the second image we have in our database, or the second, not second image, but M1092156991RE is the second image that we have in our database, and this is representing the image itself in the image slices for this particular image that are all at a scale of 0, or where all the image slices have a area of 450 pixels by 450 pixels. Excuse me. And so what we're seeing here, though, is that along the right edge, there aren't any images actually. And so this is actually accurate. So what I'm going to go ahead and do is I'm going to open up another window so I can show you the reason why it's accurate. So let's first make sure. Basically, what I'm going to show you is the actual image we have. But first, I need to find it. Let's see. Here it is. Master images. There we go. All right. So going back to my OBS software, this stuff gets confusing. I'm just now like really seeing like it really gets confusing. I'm trying to make sure that you guys are able to see exactly what I'm seeing while I'm talking, because I know in the past I've like just start talking about something and I can see it on my screen, but you guys can't see it, and so it doesn't make sense. All right, here we go. Preview. This is what I want. All right. See if I can make this a little bit better. Oh wait, can I do that? Oh, this is even better actually. Let's do this. Let's move me up here and kind of make me a little bit smaller. There we go. All right. So on the far right is the actual image that we have and that we're using for our Moon Mapper app. We've taken this image and we've cut it up into little small sections. So again, remember how I said that the upper left-hand corner of an image is the origin for us? Well, with my algorithm, the origin actually now rests at the lower right-hand corner as far as my algorithm is concerned. That's how it sees the image. And so basically now it has all the little blue boxes that represent the image slices for this particular image. And so now it makes sense though as to the reason why there's no images in that green space, because if you look at the real image, that green space represents black pixels. There's no actual image there. So let's actually go back to the comments to make sure that there aren't any questions. Wait a second, guys. Looks like you guys are having some good conversation here. I went back to the comments and I'm checking out what you guys are talking about here. Excuse me. Oh man, that's actually quite funny. I read Peter's comment about a Hawking interview. That's funny. Big J is so right. I let you guys distract me. And honestly, I mean, like I said, I enjoy our side conversations. So I kind of actually encourage you guys to distract me at times, because I mean, it gets kind of boring just me sitting here just doing work at times. I love what I do, don't get me wrong, but if you just keep doing work, it can at times get tedious. Yup, it's man keeper of maps. I love the way that you state these things, but it's exactly what you're saying though. And so, as far as my algorithm is concerned, though, I want to remove the black space, or in my case, the green space. I want to reduce that because it's going to throw off my calculations that I'm doing within my algorithm, because there's no actual image there. You are so right, Big J. So, and the thing about it, the major topic here is for me to get work done. Indeed, I agree with you on that. The thing about it is that when you say it, it sounds so much better than the way I'm saying it. All right. Yeah, it's actually quite funny because I mean, I've studied physics, of course, and I've studied astronomy, and as far as like knowing the information, I know it. If someone gives me a problem to work, I can think through the problem and work the problem. But it becomes difficult at times to be able to explain to others my thought process in a way that they understand. At times it's difficult. I'm still learning how to get better at that. All right. Hey Guido. Yeah, daylight saving time is kind of sucky at time. Well, it's sucky when you lose the hour and you have to like get up earlier. All right. So, right. So I'm currently working on correcting this image. That is, I want to remove as much of the green space as possible. And to do that, I have to actually modify my copy of the MySQL database. And so that's what I was doing. I was in the process of doing that. So I'm going to go back to to scene one, and basically, let's see. How do I want to do this? I'm going to add another window. Let's see. I'm going to name this window Text Editor 2. And for this window, where is it? It's not showing up. Sorry guys, give me 1 second. I know it's here somewhere. Here it is. No, that's not what I wanted to do. There we go. Alright, so I'm gonna, can I increase the font? It's a little bit better. Alright. So you guys can actually see. This is my attempt to play around with modifying my copy of the MySQL database. Oh, I see the reason why it's doing that. Alright, let's do this. I'm going to expand this. Go back here. Do this. And then I can probably do that. There we go. All right. So in the top window, I'm showing the code that I'm writing to make modifications to my copy of my of the MySQL database we use for CosmoQuest. And before today, I've never needed to ever do any like really serious modifications. But to be able to remove the green space in this image, it being generated by the information that's in our database, I have to be able to modify the database. So that's what I'm currently doing right now. I'm learning how to do that. You guys can kind of see what I've been doing here. Making little notes as I go. And so far, I mean, I'm able to get it to work. And the way in which I'm getting it to work is I'm basically just copying and pasting it directly into the command prompt for the database. All right. So as far as being able to actually explain precisely what I'm doing with this is going to be difficult because I quite literally just started doing this today. But good thing that Big J's here because he probably knows how to like do these modifications, as well as some of you others as well. Extend my grid to encompass the green and flag the green scale cells. Huh. So, keeper of maps, are you suggesting that I do this within the algorithm versus modifying the database? Okay. So as of right now, I'm trying to think of how would I be able to modify the code, because as of right now, the algorithm is using that extra bit of green space to be able to calculate the pixel resolutions. And I'm not too sure exactly how to be able to execute what you're suggesting. The way in which I've set the algorithm up is that I've made some general functions. And so if I modify those general functions, it'll do the exact same. It'll treat each image the exact same way. Whereas I only want to be able to modify only specific images. But I'm gonna give what you suggested a thought. Oh. Oh, but wait. To be able to do that, though, I would still need to modify the database. Because it gets the information for the cells from the database. I see what you're saying now, though. So in your case, what I would need to do is add entries into my database that corresponds to the green space, and then flag those particular like put a flag for those particular cells. I get what you're saying. Yeah, that would work too, actually. Hmm. That would work, but I'm not too sure if I wanna go down that route, because once I'm done with all of this, I'm going to submit it to our lead programmer, Corey, and then actually that's a so Big J. Quick question: once we've made changes to our MySQL database, who exactly would we request to be able to implement those changes in in the actual database? You're actually right. That would be a yeah, you're right. That would be the better option to simply add information versus changing already established information within the database. You've given me something to think about now. Huh. Yeah, let me think about that for a second, actually. So let's go back here. This is the wrong image. Sorry, guys, for getting silent there. Yeah, that's what I was thinking. See, this is the reason why I love our conversations because you guys are giving me other perspectives to think about. Well, this is my own personal copy of the database. So I mean, I can do whatever I want with it actually. But hmm. Okay. So if I were to add entries, how would I go about doing that? My current thought was set up on just modifying specific values, but adding entries might be a little bit easier. Hmm. Sorry, I'm gonna keep trying to make sure I keep talking about what I'm doing here. So right now I'm thinking about instead of, but wait, there's the whole situation of me being able to still be able to identify a particular image as a fake image to ignore. Wait, no, no, no. I don't. This. I don't think this is what I want to do actually. Because if I add the fake image in, even if I add the fake image in, I think it's still going to mess up my calculations for my pixel resolutions. I'm going to think a little bit more about what you said, Keeper of Maps, but I don't know if I want to go down that route actually. I think I'd prefer to just remove the pixels that correspond to that space that doesn't have any images in it. Yeah, I think for now I'm gonna stick with that actually, and that might change over time. So do you have an image quality flag? So yeah, that's one thing I'm concerned about. I don't think I have any sort of flag. So the information that we see here, so I'll scroll up. Let's go to the very top of this. Oh, you know what? Let's just do this. Select images from image sets. Let's limit 1. All right. And so basically, this is all the information I have. I have an ID, image set ID, application ID, name, file location, priority, pre-marked, done, sun angle, details. So, yeah, we don't have any sort of like image quality ID. And I really don't want to end up like modifying to add another column for that. So yeah, that would be another issue. I would need to be able to. Okay, so if I put entries in and I indicate that the width and the height of that particular image is 0 by 0. Yeah, I'm still worried about a few other things though. So actually, let me take a step back and explain some more stuff. So the priority field is give me 1 second. I don't even think we currently use this field actually. But priority basically indicates whether or not I believe the image is still in circulation, whether or not we're still requesting citizen scientists to mark or identify features within the image. It's been a while since I've looked at that particular field, but I think that's what that field indicates. Let's see if that changes. Let's see. Let's do the first 10. And their priority values are all the same. Or here, a value of 25. So I could modify the priority value. Oh, my back. No, I was just sitting here thinking about what you're saying. Okay. Ah, I'm gonna think further about what you're saying. But for right now, okay. But for right now, I think I'm gonna go ahead and still. I can't laugh right now. It sucks. I can't laugh. Every time I laugh, I got a cough. But move south and be less frozen. Yeah, that's right. Move to like a close to the equator, and you'll be just fine. Well, thank you guys for joining today's stream. You guys have actually given me some more to think about. The idea of being able to simply add information to the database might be the better option. And then use that added information to be able to discriminate certain regions. Right. So I believe the priority field basically indicates whether or not an image should still be in circulation. That is, should it still be used by our citizen scientists for marking craters? Oh wait. Um. So okay, I think I understand what you're saying. So in this situation, we're basically going to encode information in the black space and then use that information to be able to discard it from the general analysis. Yeah, but the problem with that is that, all right, so let's actually go back to the image. All right, so essentially what I would end up doing is creating more images, and let's just say we colored those images like pink or something. And so basically the pink images would fill in the rest of the green space. But now my major issue is that as far as the green background's concerned, the green background that's being generated knows nothing about, the image slices. And it's that green background that's being used to calculate pixel resolutions for my algorithm. So even if I were to add more images and then flag those images as being fake data, it still wouldn't affect how the image's boundary is being generated. It wouldn't affect the green background, is what I'm saying. And it's the green background that I need to be able to modify. But if I modify the green background, I have to also modify the information for the image slices for the blue cells. Right. But then the problem with that, even if I do that, I'm still worried about how the boundary region, which is represented by the green background, um, I'm worried that that's not going to be affected, and that's one of the things I have to change. I feel like I might not be explaining this properly or fully. So let me start from the beginning. So the green background represents the the bounding region for the image. So yeah, I think it's exactly what you're saying. So prime example is if my bounding region for my image is, and I'm not going to use exact values, but if it's 10 degrees in latitude by 10 degrees in longitude, but then I change it to become 10 degrees in latitude and 20 degrees in longitude, you'd go from having a square green region to having a rectangular green region. Actually, you know what? We might have to like continue this conversation in Slack because I think I really want to see what you're talking about. So yeah, I agree with you. I need to exclude the green cells from the calculation. But the way in which I was thinking about doing it is just by simply saying, "Hey, let's remove those pixels from the lengths along." You're absolutely right. The only issue is that the image I'm actually showing here is a section of the fuller image. So if I were to go back to, let's say, let's do this. Let's go back to the internet. And you're right. I should have in the actual fuller image, there are black regions along both sides of the image. But the image that I'm actually showing is only a section of the fuller image. So I need to do this. Let's go here. Let's see if you guys can see what okay. Let's not do that. Let's zoom in. So there's a lot of complexities to this particular problem. One of the complexities is that the image I'm about to show you is going to be either flipped or rotated relative to the image in our database. So, let's take this and move this over here. It's going to slightly cover me up, but that's okay. And I'm going to now zoom or scroll and zoom. Here we go. So, LRO's image archive has the fuller image. Our database has a section of the fuller image, which is what I'm showing on the left-hand side of the screen. I've zoomed in on the region that corresponds, or zoomed in on a region in the LRO image that contains our image section. And you can probably tell, well, hopefully you can tell, that LRO's image is vertically flipped relative to our image. Maybe if I zoom in a little bit more, it might be a little bit more apparent. The key thing is to look at this triangular feature in both images. It's the same feature, it's just that it's flipped. And so in one of my previous streams, I was concerned about this and had to modify my algorithm to account for the orientation of the image, which is what we were talking about before Keeper of Maps. And so I was able to get that problem solved, and thank you a lot for the conversations we had on Slack for that. Let's see. Go back to the comments. Is my voice back? Can you guys hear me just fine? Thank you, Susie. All right. And so orientation problem fixed. The issue now is, of course, how to deal with the black space in the image. And so I do like your idea of just being able to add information to the database and then using that information to discriminate certain regions. But it's hard for me to imagine exactly how I would do that, where it only affects certain images but not all the images. And I mean, I can, of course, modify the MySQL database to achieve this, but it's hard for me to see exactly how to do that by simply adding information. My idea was just to take away the information or just change it completely. But your idea is actually the safer way of doing it. If you add something, of course, you can always just, if it's wrong, you could just remove it, and you go back to what you initially started off with. But in my situation, I'd be completely like essentially changing the data itself. Instead of it being like your situation, 3 plus 5 is equal to 8, I could take away the 5 and get back to 3. In my situation, I'm just going to take the 3 and make it into a completely new value. Which could be problematic, of course, if I'm not keeping track of those changes. Alright, guys. The time is now 1:13 p.m. Thank you guys for oh, God. Excuse me. Felt a cough coming on there. But thank you guys for hanging out with me here, discussing the science with me, and giving me some new perspectives. I will be back on this Friday. I believe I should be done with this. Well, I should definitely be done with this by Friday. And maybe I might have an actual problem we can work through. But if you guys have any suggestions, just message me on Slack, and I'll see it and I'll respond. So, guys, thank you guys, and until next time. Next time being Friday at 12 o'clock p.m. Central Time. All right, guys. Bye. Yeah, no, Peter. 15 minutes over. I'm sorry. I hope I didn't like mess up any of your plans. But okay. Bye, guys.